Hey guys, welcome to Pre-Calc lesson 6.4 on parabolas. Before we get into parabolas though, I'd like to do a warm-up on an ellipse, and this will include everything going from general form to standard form, graphing, identifying all key points. So if you notice in the directions, it doesn't tell you it's an ellipse. It says rewrite in standard form, identify all key points in sketch. So how do you know it's an ellipse going in? Because in our general form, A does not equal B. You've got to recognize that. You've got two squared terms, it's addition, and A does not equal B. That's going to be an ellipse. So let's get that into standard form first. Group our x's. Group our y's. And move the constant term to the other side. I'll subtract that over. Next, I need to take out a GCF. So with the x's, I'll take out a 5. That leaves me with x squared plus 6x. With the y's, I take out a 2. That leaves me with y squared minus 4y. And that equals negative 33. Now I'll complete the square of the x's. Half of 6 is 3. 3 squared is 9. But remember, you're not really adding 9 to this side of the equation. We're adding 45. 5 times 9. So that's what I'm going to add to the other side to keep it balanced. With the y's, half of 4 is 2. 2 squared is 4. But you're not adding 4. You're adding 8. Okay, so now let's factor. 5 times x plus 3 squared plus 2 times y minus 2 squared equals, add all those up, you get 20. Now remember, your standard form has to equal 1, so I'll divide both sides by 20, and I will get x plus 3 squared over 4 plus y minus 2 squared over 10 equals 1. That's my standard form equation. So now from that, right away, I can get 3 pieces of information. My center, negative 3, 2. My x-pole, square root of whatever's under the x, that's going to be a 2. And notice that's the smaller of the 2. That's going to be your b value also. Y-pole, square root of 10. This is the first time we're seeing an x or a y-pole that's not a perfect square. That's going to be approximately 3.1, and that's going to be your A term. So now I can start sketching this. Center is negative 3, 2. My x-pole is 2. So 1, 2, that direction, 1, 2, that direction. Now your y-pole is square root 10. For the purposes of our sketch, we're going to approximate that as 3.1. So from our center, we're going to go up 3.1, 3, 4. So I go just past 3. And that's going to be one vertex. And I go down 3.1. I'll be approximately there in my sketch. And that's going to be vertex 2. So now I can make a somewhat accurate sketch with these coordinates. And I can identify the vertices. Let's see, V1 and V2. Now remember, I know the coordinates of my center, negative 3, 2. So what I'm doing to get the coordinates of the vertex, because I can't really rely on the grid, right? It's not exact enough, is I need to go up square root 10. So I'm taking the y coordinate, I'm going to add square root 10 to it. That'd give me V1, and then I'll subtract square root 10 from it. And that would give me V2. Okay, so that's going to be negative 3, 2 plus square root 10, negative 3, comma 2 minus square root 10. And those are the coordinates of your vertices in simplest radical form. So now let's find the foci. Remember, for an ellipse, it's c squared equals a squared minus b squared. So that's going to be 10 minus 4, that's 6. So c equals square root 6, which is approximately, I don't know, ballpark it, 2.4. So from your center, you go up about 2.5. That'd be F1. Go down 2.5. That'd be F2. So now what are those coordinates for F1 and F2? Well, what's kind of nice about this is if you notice, your foci are always on the same axis as your vertices, the major axis. So the coordinates of the foci are are going to be very similar to these. The only difference is I'm not going up square root 10 anymore. I'm only going up square root 6. So basically, you just take this coordinate here and you replace the square root 10 with the square root 6, and that's f1. Do the same thing with v2, and that becomes f2. So this will be negative 3, 2 plus square root 6. f2 is negative 3, 2 minus square root 6. There are your coordinates of the foci. Last thing we'll do is get eccentricity. Eccentricity, if you remember, is c over a. C is square root 6. A is square root 10. I would throw that into the calculator. And I got 0.775 to the nearest thousandth. Okay, so the only thing we didn't talk about here is LR. We're going to mention that again. You'll see it on a work session. But for now, that's a good review, good summary of ellipses. Now let's get into parabolas. So first, what's the definition of a parabola? The definition is the set of all points equidistant from a fixed point, and that's your focus, and a line, and that's called the directrix. So I'm going to make a sketch on the right here of what we're talking about. This line is a directrix, and this point here will be the focus. If I calculate all the points, or I plot rather, all the points that are exactly equidistant from this point and this line, here's what we would do first. Find that segment, find the midpoint. Then I'd find a series of segments that are congruent, equidistant. And all of these points along the way, obviously you do this on the other side, and end up making a parabola. So it's going to kind of look like this. And what I know is, if I sketch these in, those two segments are congruent. Those two segments would be congruent. Those two segments would be congruent, so on and so forth. So it's kind of a neat way to define a parabola. And I know we've done these equations before, but this is going to be a little bit more challenging than we've seen in the past. So first of all, our standard form equations. Okay, there's two, but also both of these would be what we call either a happy or a sad parabola. There's another type of parabola we're going to see, and it's going to look like this. X equals a times y minus k squared plus h, or x minus h equals a times y minus k squared. So the vertex in all four of these is going to be hk. What I want you to notice here is the vertex is always hk. H is always with the x, and k is always with the y. It doesn't matter which version of the equation you're using. Also, if you remember from last year, we have this formula, a equals 1 over 4p, where p is the distance from the vertex to the focus. So if you look up above, the vertex to the focus, that distance there would be p. Or distance from the vertex to the directrix, right? Because those two are equal, that's also p, because these two are equal. Now, in addition to that, I want you to note that we can just switch the p and the a in that formula, and p equals 1 over 4a. That's super important if we're working backwards from a graph to the equation. Now, I'm not a huge fan of formulas. Those of you in my class know I prefer patterns. But those of you that are good at memorizing, I'm going to give you a couple formulas here. The focus is going to be h comma k plus p, or h plus p comma k. The directrix is going to be y equals k minus p, or x equals h minus p. The other thing I want to add right now before I move on is general form. And how do you know it's going to be a parabola? So it could look like this. ax squared plus by squared plus cx plus dy plus e equals 0, except you're not going to see both of these. You're only going to see one of those because a or b equals 0. So you know it's going to be a parabola when you only have one square term. So it could look something like this, or maybe we don't have that, and it looks something like this. Okay, what I want you to focus on is the pattern. So what I mean by that, if you see y equals positive x squared, you know that that parabola is going to look like this. Directrix, focus, and your parabola is going to open up. If you see y equals negative x squared, it's going to look similar to the one we just did, except it's going to open down. So there's your directrix, there's our focus, our parabola would look like this. If you see an x equals positive y squared, that's going to open to the right. So our directrix is going to be here. Focus would be there. And our parabola would look like this. And then lastly, obviously, process of elimination. If you see x equals negative y squared, then it's going to open to the left. So our directrix would be here. Focus would be there. And our parabola would look like this. So what I do, rather than memorize all these different types of formulas and try and figure out, well, which one is it, I'm not sure, let's be visual. All right, so if you know it's y equals x squared, happy parabola. Y equals negative x squared, sad parabola. X equals y squared, opens to the right. X equals negative y squared, opens to the left. Okay, so let's use that, do a couple examples here. It says sketch the following parabola, finding the vertex, focus, and equation of the directrix. Now, some of you can work with this standard form. One of the things that I recommend, you don't have to do this, but I like to get this number over on the left side of the equation. You'll see why in a second. It makes it kind of consistent with what we've done so far with circles and ellipses. So I would write this as y minus 3 equals negative x minus 4 squared. I would do that first because that helps me get the vertex. Remember, the vertex is hk. H always comes from what's with the x, the opposite of what's inside with the x. So that's going to be positive 4. The k always comes from whatever's with the y. It's the opposite of that. So that's going to be positive 3. And that's one of the reasons why I like to kind of group it like this. It's because we find that vertex the same way we'd find the center in an ellipse or the center in a circle. So my vertex is going to be 4, 3. Okay, I can plot that over here. There's my vertex. The next thing you need to recognize is the pattern. It's y equals negative x squared. That looks like this. So maybe we'll make a quick thumbnail sketch right here. Now, how do you know, we don't want to make just a random parabola, but how do you know how wide to make it? Remember your pattern. If a equals 1, we go out 1, down 1. Then we go out 2, down 4. And that's really as far as we would need to go here because you can't fit any more in. This number in front of the square term is our vertical stretch. Well, for this one, we don't have a vertical stretch. Okay, so I'm going to go over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4. And I can sketch that in. Okay, there's the vertex. I need to identify that. The focus and equation of the directrix. Now, don't sketch this in yet, but I know my directrix has to be up here and my focus has to be in here, right? The focus is always inside the parabola. But how do you get that exact value? How do I know how far away this is? We use that equation. P equals 1 over 4a. I need the distance. Well, what is a in this case? A is 1. It's not negative 1 because we're talking about distance. It's just 1. Okay, so it's 1/4. So I'm going to sketch my directrix. I like to do it as a dashed line. And my focus will be right there. Well, what's that equation? Equation of the directrix. First of all, it's horizontal, so it's going to be y equals. And then what is that value? Well, it's going to be 1/4 above this. So that's 3 1/4. And your focus is going to be this coordinate here. Well, it's going to be 4 comma 3 minus 1/4. So 4 comma 2 3/4. You're going to see lots of fractions with these parabolas. Okay, next it says get the following into standard form, find the vertex, focus, directrix, and sketch. These are actually a little bit more challenging, I think, than just an ellipse or a circle or a hyperbola because only one of the terms is squared. So what I want to do is I want to group my square term and then get everything else to the other side. So it'll be a negative 4x plus 11. Now I need to complete the square. Well, half of 2 is 1. 1 squared is 1. I'll add 1 to both sides. So this is going to give me y minus 1 squared equals negative 4x plus 12. Here's the part that's a little bit tricky. You want the a value over here, which means I need x by itself. So if you want x by itself, I'm going to divide both sides by negative 4, which is the same thing as multiplying by 1/4. So maybe I'll just show that. Also, I want my squared term on the right, so I'm going to kind of flip-flop these sides. This will be x minus 3 equals negative 1/4 y minus 1 squared. Right, because I just divided both of these by the negative 4, sorry, and took this as 1/4, negative 1/4 of y minus 1 squared. Okay, there's my standard form. First thing I'm going to notice, it's x equals negative y squared. It's going to look like this. All right, so quick thumbnail. That's what my parabola is going to look like. Let's identify some parts. My vertex is going to be the opposite of what's with the x. So 3 comma 1. Okay, I can put that in, 3 comma 1. That's going to be your vertex. Again, I know it's going to open up this way, but I want to make an accurate sketch. Notice your vertical stretch is 1/4. So normally we go out 1 and over 1, but I'm only going to go out 1, up 1/4. So these will be my points here. And then normally I go out 2 over 4, but I want to go 1/4 of that. So that point's going to go here, and that point will go there. And that's probably good enough to make a quick sketch. So there's my vertex. And then I need to get the directrix and the focus. So remember, P equals 1 over 4a. That's going to be 1 over 4 times 1/4. That's just 1. Oh, that's easy. That distance is going to be 1, and my directrix is going to be 1 away. Coordinates of the focus will be 2, 1. And your directrix, it's a vertical line this time, so it's going to be x equals 4. Great. Let's move on. Now I want you to find the equation of the parabola given this information. You know the vertex is 0, 0. That's good. And the focus is 0, 2. So here's my focus, 0, 2. I know it's got to open up. Okay, so if it opens up, I know I'm looking at y equals something x squared. Now, since my vertex is 0, 0, it's really like y minus 0, and that's x minus 0 squared, but I don't need to put those in. What I need to do is I need to calculate this value of A. That's 1 over 4p. And in this case, p is going to be 2. That's the distance from the focus to the vertex. 1 over 4 times 2, that's 1/8. That's 1/8. And there's your equation. Example 4 wants us to find the equation of a parabola that has a vertex at 2, 4. Let's plot that as the vertex. And passes through the points 3, 5. There's 3, 5 and 3, 3. So remember, that's your vertex. The only way to draw a parabola that goes through those 3 points is like this. Okay, so it's going to be a sideways parabola. Sketch that in so we get an idea. And we need to recognize that if it's a sideways parabola, that's x equals positive y squared. So I'm going to start my equation over here. X, give yourself some room, equals positive y squared. Now the reason I'm spreading it out like this is because I need to incorporate my vertex. It's going to be x minus the x coordinate of the vertex equals some value of a times y minus the y coordinate of the vertex squared. Well, I can get that part here, x minus 2 equals y minus 4 squared. Now, what's going to go here is some value of a. Well, normally we say, oh, a equals 1 over 4p, where p is the distance from the vertex to the focus, but where is that focus? Okay, well, if I don't have that, do I have a directrix? No. So I didn't give you a directrix or a focus. That means I can't do this. All right, I need to use a different method to find a. And here's what we're going to do. We're going to use one of the 2 points. All right, so if x is 3 and y is 3, what's that value of a going to be? So what I'm going to do is I'm going to plug a 3 in for the x here. I'm going to plug a 3 in for the y there and solve it for a. Okay, I'll do that down below. So instead of x, I'm going to put 3 minus 2 equals a. That's what I'm solving for. Instead of a y, I'm going to put a 3 minus 4 squared. Okay, 3 minus 2 is 1. A times 3 minus 4 is a negative 1 squared. While negative 1 squared is just 1. So a equals 1. Oh, so that's just a 1. You don't need to put it in, obviously. That's your equation. Okay, so now let's talk about the reflective properties of parabolas. And what's really neat about this, first of all, there's many different applications. Satellite dishes, headlights. But from the focus, anything that's emitted and reflected off the parabola comes out parallel. So if you notice, all of these are parallel. Now that works both for leaving the parabola and coming in. So this is how a satellite dish would work. The satellite signals come in parallel and they all reflect off the parabolic dish and bounce right to that focus. So even though individually each one of these waves is too weak to be read by the receiver, the parabolic dish focuses them all to that receiver. So it amplifies that signal. Another application is in suspension bridges. This shape right here, once the cables are attached and they're load bearing, that shape right there is a parabola. Okay, so you guys can read about that also, but I want to move on and practice a couple of these because this lesson is dragging on. Example 4, paraboloidal shaped car headlight is 8 inches wide and 4 inches deep. Find the exact location that the bulb needs to be placed to utilize the reflecting capabilities of the headlight. So first of all, I'm going to just kind of sketch what we have here. So here's the headlight, and there's the back of that headlight, and that's the parabola. Okay, 8 inches wide. That would be this right here. And the depth would be from the lens to the back of it, and it's 4 inches deep. Find the exact location the bulb needs to be placed to utilize the reflecting capabilities. So basically what happens is there's a bulb here somewhere, right? And all that light bounces off the reflector and comes out parallel. So now we need to do is we need to figure out, well, where are we going to put that? So what I want to do is I want to take a cross section of this headlight. Actually, I should stop it right here. And put that on an XY plane. Okay, let's make a sketch. The easiest thing to do is take your vertex and put that at 0, 0. All right, so my vertex is going to go here. Use a different color. There's my vertex. And then I sketch it. Now, you don't have to do this. I just think this is the easiest, right? That's going to be y equals x squared. That's really poor. Let me fix that. Okay. So here's your headlight. What do we know? 8 inches wide, 4 inches deep. So if I'm on a coordinate plane, I know this coordinate right here. That's 4, and that's 4, so that's 4, 4. Okay? What's the equation of this parabola? Well, it's pretty easy to get. It's going to be y equals something x squared. Right? And that's what I want to find. I want to find this value of a. But remember how we do it. I know the xy coordinate, 4, 4. When x is 4, y is 4. So I'm going to put an a here. I'm going to put a 4 in for y and a 4 in for x. I'm going to solve that equation. Okay, so I've got 4 equals a times 4 squared. Well, 4 squared is 16. Let's divide by 16. 4 over 16 is 1/4, so a is 1/4. Well, what good does that do me? Remember, the whole goal here is to find out where is my focus. The distance from the vertex to the focus is p. We've got that super important formula, p equals 1 over 4a. We just calculated a to be 1/4. Well, it's just going to be 1 over 1, or 1. So the distance from the vertex to the focus is 1. Now, how would you describe it? All right, well, you would say, place the bulb 1 inch from the back of the headlight. And in parentheses, you might want to just mention that's really the vertex. Back of the headlight, the vertex. All right, our last example. A paraboloidal shaped satellite dish is 24 inches wide at its widest part. The location of the receiver is exactly 10 inches from the center of the dish. Find the depth of the dish. So we got something that kind of looks like this. There's our satellite dish. And we've got this receiver that comes out like so. 24 inches wide would be that part of the dish there. And the focus is at the end of that receiver. And that distance to the back of the dish is 10 inches. The question wants me to find the depth of the dish. So that's this part right here. What we're going to do, like we did up above, is we're going to put this on a coordinate plane. Okay, so the dish kind of looks like this. Cross section. It's not the best drawing. And what I know is that that distance is 24 inches. Which makes this distance here 12. All right, so I'm going to be able to get this x coordinate's going to be 12 something. The focus is 10 inches. So I know this distance here is 10. And the distance from the vertex to the focus is what we call p. So p equals 10. This coordinate here, I know the x coordinate is going to be 12. I do not know the y coordinate. I'll just call it y. Now y is actually what I want for my final answer. It's going to be the depth of that dish. Okay, so what do we know? I've got an equation of a parabola. Y equals ax squared, right? Because we always like to put the vertex at 0, 0. We like to have it tip up. So it's always going to be y equals ax squared for these application problems. I'm actually looking for this y value. So if I want this y value, I've got to figure out what a is, and I've got to figure out what x is, plug both of those in the side, calculate that value, and there's my answer. Okay, so now, to get a, I'm going to take 1 over 4p. P we said was 10. It's 1 over 4 times 10, 1/40th. Okay, so y equals 1/40th times x. Where do you get your x? Right there. It's 12. 12 squared. So y equals 144 over 40, which is approximately 3.6 inches. And you just have to answer the question. The dish is 3.6 inches deep. It doesn't say what to round to, so we'll just go nearest tenth. All right, that finally concludes day 4, lesson on parabolas. Please don't hesitate to reach out if you have any questions whatsoever. And thanks for watching. We'll see you in class soon.